Hi, welcome to Internet of Things tutorial from Robojax. In this video we are going to control the speed, direction and start and stop of a DC motor with ESP32 over Wi-Fi using MQTT from a cloud provider, in this case Adafruit. We are going to control the speed and direction of the motor and start or stop of the motor like this. So from the screen, and as you can see, we can see on the serial monitor the speed, direction, and we can change the direction of rotation. We can speed it up, slow it down, and stop it or start it. The latency is very low. It depends on your internet speed, and also I set it half a second. Let's get started with this. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. In the previous lessons in this course, we learned how to use L293D motor driver with ESP32 and ESP32 extension board from SunFounder. All these components are part of the kit that comes with the learning kit. And now we are going to control the speed of this motor by increasing or decreasing the speed. We are changing the direction of rotation and start or stop using MQTT protocol. MQTT protocol is such that we are subscribing to a topic that we create, and in this case we are creating a motor control topic, and this board using Wi-Fi will connect to the service that is provided by Adafruit. This is Adafruit IO, and we are subscribing, and this motor can be turned on and off or speed change and direction. We are using here as a publisher, so we need two elements. One is publishing. We are publishing information about the motor in terms of direction of rotation, speed, or start and stop, and this goes to a broker, an MQTT broker, and then this motor can be turned on and off based on the information that has subscribed. So this MQTT, the Adafruit service, is free. We can use it for limited amount of control or dashboard that we create, so you can test and learn it. We have already explained the motor driver, and how to control. I'm not going to explain that. Please watch that. The link will be below this video, or it will just appear somewhere on the screen. And we're just going directly to showing you the wiring and how to set up MQTT and the Adafruit IO service. To understand how to turn on and off the motor and also control the speed of a motor, we have to understand that this cannot be connected directly to ESP32 or any other microcontroller like Arduino or STM32 or any other microcontroller. For that we need a special circuitry, but before that let's see how we can control a motor. Now we have a battery and we have a motor one terminal of the battery is connected to one terminal of the motor, and the other wire is connected to the other terminal, and as a result this motor will rotate. And if we disconnect this wire here at this point, this is a switch, so we can connect it and the motor will rotate, and disconnect it and the motor will turn off. This switch also can be moved to the other line, other wire. The same way we can disconnect it, the motor will turn off, and connect it and the motor will turn on. Now if we pay attention here, if for example in this particular motor, if the positive terminal is connected to one of the wire that is labeled as positive or negative, doesn't matter, for example in this wire, and the other side is connected to this particular motor is rotating in counterclockwise direction in this way. Now if we switch the wire, this positive which was in here, if we move it to this location, and the negative which was here, move it there, then the positive is coming here, the other side is connected to the negative, and as a result the motor will rotate in clockwise direction. Before it was rotating in counterclockwise, now it is in clockwise direction. So we learned that if we change the polarity of the power supply to the motor direction of rotation in DC motor will change. If we put some kind of mechanical switch that can do this all at once, so we can have this motor controlled in both direction. Now let's see what happens from positive. We have this gray shows one switch which has 3 terminals, and the other gray is also another switch which has 3 terminals. These 2 switches are connected together, so you can move them together. When you push it, both of these contacts will move. So the positive is now connected via this switch, and in here it's connected to the negative, and the positive of the motor is connected via this contact, and it goes to the negative, and as a result the motor is, for example, rotating in counterclockwise direction. Now if we move this up, now let's see, this was like this, now it's moving it up. The positive before which was going to the negative terminal, now this negative is not connected. From here it gets connected to the positive, and the negative of the motor which before was to the positive, now it is connected to this terminal and it is connected to the negative, and as a result the motor is rotating in clockwise direction. Before it was counterclockwise, now clockwise. So the other principle that we just learned is if we have some kind of switch that can connect or change the polarity for us, we can control the direction of rotation of the motor. Now to control the DC motor with Arduino board, with ESP32, any other board, you cannot connect it directly like that, because this motor needs a lot of current, and a microcontroller cannot supply that amount of current. So we need something between the microcontroller or ESP32 and the motor, which is called driver. And because this is an inductive load, there is a lot of winding. Usually for protection we put a diode. This diode is just for illustration. Most drivers that we use will have their own diode built in. We need this L293D motor driver. L293D, the D means diode. It has a diode. It has 4 drivers, and each driver has 2 pins. One A, for example, and then enable pin, and then it has output. 2 input and 1 output. To here, when we use L293D, it has, because I just mentioned, it has 4 drivers, 1/2 bridge. If we use 1/2 of the driver, the motor can be rotated only in one direction, and it has 1 input pin and enable pin. So you enable it, and then from here you can send, for example, pulse modulation signal, and the motor will rotate in one direction, and the other wire is connected to the ground. And if we use 2/2 bridge, then it will become a full bridge. The other side, which was connected to the ground, is now connected to the same another driver, and then the positive will come and the negative will go to other driver, and both of these are connected to the same enable. So we enable them together And as a result, this motor will rotate, for example, in counterclockwise direction. Pay attention that the lower driver is high and the upper is low. Now, if we set the lower to low and the upper high, because it was low, now it's high, then the enable is high, then the current will change the direction, and the motor, which before was running in counterclockwise direction, now it will run in clockwise direction. And here is a data sheet for L293, and there is X, so it's D. We are using D version. It has quadruple half H driver. What is the meaning of half H? Each of this is half bridge driver. Two of this together, two half will become one bridge, and two of this will become another bridge. So we have two bridge in one package. However, just remember that operating voltage is 4.5 to 36 volts, and the current per channel is 600 milliampere. It means that from this driver, 600 milliampere will pass either this way or that way. So this is half bridge, another half bridge, so they become full bridge, so we can control one motor. But if you connect one motor to one half bridge, it will be controlled only in one direction, not both. In this case, it shows three motors, but only one is controlled fully, clockwise and counterclockwise, but these two are just rotating in one direction. So with L293D, we can control only two motors fully, because these two will become one full bridge, another full bridge. Let's get introduced to MQTT. MQTT stands for Message Queuing Telemetry Transport. Why we need it? Because it's lightweight and efficient. MQTT is bidirectional. MQTT can be scaled to millions of things, and it uses reliable messaging delivery system. It is secure, and it is persistent over unreliable network. So first we have to understand the elements of MQTT. We always need to have a broker, and we have MQTT subscriber, we have MQTT publisher, and the most important thing in the broker is the topic for which the messaging is being published or subscribed. Now, this is Internet of Things from MQTT.org, and we have client, broker, and another client, which is subscriber. In this case, we have a temperature sensor, sends information to the broker, and the temperature is listed or queued on the cloud, and our subscriber can read or fetch a particular topic. In this case, temperature. The topic is temperature, and we read the temperature. And if we use a microcontroller such as Arduino or ESP32, in this case we use it as a publisher, and we have MQTT broker. In this case we are using Adafruit IO, and then we have MQTT client, in this case a subscriber, a mobile device or a computer. So the temperature from temperature sensor is read by ESP32, and because this acts as a publisher, we are publishing it as a topic of temperature to the broker, and it is being listed and queued there. It just waits until the request comes or the device is connected, so we can read the temperature on the screen. That's how it is used as a publisher. Now let's see how we can use it as a subscriber. We have Adafruit MQTT broker service, and then ESP32 is used now here as a subscriber, and we have subscribed to a topic called LED. And then MQTT client is publishing on off to the MQTT broker. So when they touch or click on icon on or off, the information is queued here for the LED topic. Remember, this is a topic, and we can have millions of topics. So one topic is called LED. And because we have subscribed to that topic of LED, the information comes. Either that topic says hi or low or on or off. Depending on that, we interpret and read the information, and we turn on and off the LED based on the action that is taking on the screen. Now let's click on Adafruit IO. We're going to create an account. Click here on the sign in. Let's create an account here by sign up. So once you open an account, log in. Now once you logged in, you can click on dashboard here. Let's create a new dashboard, and let's call it motor control. You can, if you have multiple motors, motor control 1 or whatever motor with some word, just type. This is done. Let's go on feeds. I'm going to create a group so we can have all the elements inside the group. Inside the feed, click on groups. Let's call it DC motor and then create. Now this has been created. It has no feed. Click here, and we are creating 3 feeds. Speed, and then direction, and start. So this is the DC motor. We have created 3 feeds, and you see DC motor direction, DC motor speed. I could have typed just motor, and it will be motor.direction, motor.speed. So it's up to you. Now, after creating this, go back to the dashboard and click on motor control dashboard. It's empty. Click on this icon and then create new block. For the motor speed, we need slider. Click on slider, and then under the motor, select the speed because the slider is for the speed. Click next. We type here a text. The text appears on top of the slider. Let's call it speed, and then the value is 0 to 100%. That's correct. This 10 is the step. Let's set it to 1 so we can set even with a resolution of 1%, so 0 to 100%. And then here you can set the label like percent. This percent will appear 0%. Now create another one, new block, and this time we create a toggle switch, and then go under the motor, and then this will be direction, and click next. Type here direction, and then on text, and then on value. On text will be CW, and then the value would be 1, and then off will be CCW, and the value would be 0. So pay attention to the value. Value, we want 1 and 0 inside our code so we can read it, and this is just a text that appears here. Click, and this is done. Now let's create another block, new, and this time again toggle switch, and then go under the motor, start. Select the start, next, and then here start. So you can say on and off, and here on value should be 1 and off value should be 0. If you don't put the value, this on and off will be passed. It says uses on text f blank. So make sure to type 1 and 0. Now we have set all this and it's ready. We can get the key by clicking here and the username and key, which I'm going to show you again. So we need this inside the code. When you use ESP32 with SunFounder's ESP32 camera extension module like this, it comes also with a battery on the package, and it comes a built-in charger so you can connect it and charge it and disconnect, and later on you can use it with a lot of power so you can power up your application very easily. Now let me show you the wiring. This is the wiring diagram that I have followed. and prepare this because this is very simple. I have created this. Blue is my negative on both sides, and then the red is my positive, and I've got a ground wire and positive. The positive has not been used, but I've connected the red to this side using this wire, so both sides has 5 volts, and I'm using external power. Then black is connected to the negative line, and this is connected to external 5 volts because the DC motor needs a lot of current and the USB will be overloaded. So I will not suggest connecting it directly to 5 volts of this module. So I'm going to remove these 2 wires first. First, this chip has a dot here. This dot is pin 1, 1 to 8, and then 9 to 16. Now the pins are shown here. Pin 1, pin 16, and pin 8 are connected to 5 volts. Now pin 1 is connected using red wire to 5 volts to this red line. As I said, this is my 5 volts which is connected here. And then pin 8 is connected to 5 volts, and pin 16 is connected also to 5 volts to the red line. That's done. Only one wire from pin 4 is connected to the ground. So 1, 2, 3, 4. Pin 4 is connected using this black wire to the ground. Then the signal is connected, pin 2 is connected to 13, pin 7 is connected to pin 14. And here that's 13 and that is pin 14. You can connect it directly in here, or if you don't use this extension board, you can use directly pin 13 and 14, which are labeled here. And I'm connecting pin 13 and 14 to pin 2 and pin 7. Pin 2 is here, and pin 7 is the last second. So this is done, and it is connected to here. And then ground is connected from this line using black wire to the ground, and I've connected it to 5 volts, but the 5 volt is not connected because I'm using external power. Now the motor will be connected. This is my motor. It has been connected to pin 3, and the other side is connected to pin 6. So one wire, doesn't matter which one, because if you connect it in different ways, the direction of rotation changes. So it's up to you whichever way you connect. One wire is connected to pin 3, and the other is connected to pin 6. Like that, and the wiring is completed. Now let me explain the code. I have written this code here. The first line, it says Boolean debug false. This is the value that if you want to see the information on the serial monitor, and let me connect it, the information that is displayed in here is coming from the serial monitor, and it will be printed if I open the serial monitor. This information, if it is set to false, it will not display. If you want to display it, make it true. At the moment, the code that has been uploaded is true. So if you want to disable this, just change this to false. Pin the motor A, motor 1A, motor 2A. So this is pin 1 and pin 2 for the motor A. I've defined pin 13 and 14. This is the same as the introduction to the motor pin. And then this is a frequency for pulse width modulation. The resolution is 8 bits. And then we are using channel A and B of pulse width modulation of the ESP32. These are just a text CW, CCW. So it is displayed in here. This CW, CCW is coming from here. Please do not change this. And then motor speed, motor direction, motor start or stop, and duty cycle. These are variables that are being updated by the code. Do not change them. This is for Wi-Fi, and then Wi-Fi secure client connection. And then we need Adafruit MQTT. This Adafruit MQTT library must be installed. If you have not installed it, let me right click and copy this text. Go to library, right click here, and then paste, and you will see Adafruit MQTT library, which shows installed. In your case, you will see the install button like that. Just click and install it. In my case, it's already installed. And then this is for your SSID for Wi-Fi, and this is for the password. make sure to respect the case. For example, if the SSID is uppercase and you type small b, it will not work. So make sure to type it exactly as it is. This is for the path for Adafruit IO service, and this is the port. Do not change them. This is the username, and this is the key which we get from Adafruit IO dashboard, and you must copy and paste it as shown there. Here, let me go there, go to Adafruit IO service, and here you will see the key. Click and you will see the key, and here the username, and you can generate and change the key as you wish, because I'm not worried if you see it. For example, if I change this and then the code will not work, I have to update it with a new key. Right click, copy, and then come back and paste it here. So that's very important. This is for Wi-Fi client, and this is creating MQTT client. We are creating an object of MQTT with all the client, service, port, all the information that are at the top of the code to get connected to MQTT service. This is the certificate, Adafruit root certificate authority. That's the certificate, and this will expire by the time that you watch this video, so we have to update it. Because we just installed the library, let's get the latest certificate from the code that is provided. Click on File, Example. You see we don't see Adafruit, all the other examples. Let's just close this and then open it again. Now after installing the library, this will be updated. So click File, Example, and now you see we see a lot of other examples. And under the example from custom library, you will see a lot of Adafruit. One is Adafruit MQTT library, and under that you will see Adafruit Secure ESP32. Click to open this sketch, and in here from line 50, the certificate is in here. Select it from here, go down until, let me increase the size. So from this bottom to in here. So select it up to here, right click, and then copy, close this, come to the sketch that we are working on, select up to here, and then right click and paste. Now the certificate has been updated, and you will not get error. Otherwise, if this is expired, you will not be able to get connected. Now we are creating a subscription object. I call it, the first one, we need 3 objects: motor speed, motor direction, motor start. And for each, we are using MQTT subscribe object instance, and then we pass MQTT library as a reference, and then username, which is Robojax /feed, and then motor.speed, again Robojax, this is username, feed, motor.direction, motor.start. These are the values that you get from the Adafruit IO service. If I click here at the feed, and then under the motor group, you see motor.direction, motor speed, motor.start. So the value must match exactly as it is, otherwise you will not be able to read it. So we are creating these 3 objects for subscription. Inside the setup, we are initializing the LEDC for the pulse modulation, channel frequency and resolution, channel A and B, because we need 2 of them. And then for pin 1 and pin 2 of the motor, we are attaching this channel, 2 channels. This is initializing the serial monitor, printing this text. This is printing just the SSID on the screen. After 1 second delay, we initialize the SSID and password for the Wi-Fi to begin. We have 2 seconds delay. This while loop checks if the connection is not true or not happened. Then after 500 milliseconds or half a second, it prints one dot continuously until the connection is established. Then the loop will exit, and this will print this value. And if I open the serial monitor, the value and if I press the reset button, you will see that we are getting connecting, and you can see, you can see in Wi-Fi connected. This is the text that is coming from here, and then it will print the Wi-Fi connected IP address. Let me stop this. Wi-Fi connected IP address, and it will print the IP. So that text is coming from here, and this is initializing the certificate for the secure connection. And I've created these two lines. First line is registering the callback for the feed. I call it motor speed from this object, the same object. I use this motor speed. So motor speed dot set callback, and here I've created this function motor speed callback, which is at the bottom of the code, and then we pass this by reference to this MQTT subscription. So this is initializing that. And then we have done the same thing for motor direction. As you can see, that is here, and motor direction callback, which is at the bottom of the code. And then the third one is motor start, which is used for start and stop, which is I've created a function at the bottom of the code with that name. Inside the loop, we are running this function to connect to MQTT with the credentials. And then every half a second or 500 milliseconds, we check the MQTT packet processing. So we are reading it. And this function is run motor, which is at the bottom of the code, which I'm going to explain. Now, motor speed callback is this function, which ends here. We are reading the message that is coming from library, and we are printing it on the serial monitor when the information comes. And then we get that message, and we store it in a variable of type string, and we call it is in string. This line is converting it to integer because the speed of the motor is an integer value. So we are storing it in a variable called motor speed. This variable is global variable at the top of the code. In here, motor speed. And in this section, we are checking the bound to see if the value is greater than 100 or less than 0. We set it back to 0. This prevents it in case if you enter incorrect information on Adafruit IO page. And after that, we get the speed using the map. We map this value, which is from 0 to 100. We are mapping it and converting it to a value of 0 to 255. The map is a function from Arduino. So the result of the calculation, which is a value between 0 to 255, is stored in the variable called duty cycle. This is global variable at the top of the code. So this will go to the motor. And now the same way, the motor direction, we are getting the value, converting it to integer. This will be 0 or 1 and stored in this variable, which is defined at the top of the code, which is a global variable. And then start stop is also a boolean or a variable of 0 and 1. The same way we get the value converted to a string, and then from string we convert it to integer. Now when we run through the loop run motor, we check this if start is equal 1. Then we run all this code, else we just send LADC write to the channel. We send 0 to A and B for both of those, and the motor will stop. Now, if it is equal 1, it means the motor should start. This portion is for debug. If the debug is equal true, it will print the motor is running with the direction CW or CCW with the motor of speed with percent. Now let's see if the direction is equal 1 or it's equal true. Then we use LADC write channel 1. We set the duty cycle, and then for channel A and for B we set 0. It will rotate in one direction. Else means the direction is CCW. We just change this. Pay attention. For A we had duty cycle. Here for A we have 0. For B we had 0. Now for B we have duty cycle. We just change the position of the value, and the motor will rotate in the other direction. And this is MQTT. MQTT function will start a connection, and it will try 3 times, and using this while loop it tries to connect every 5 seconds, and if it is connect once, twice, 3 times, every time it decrements this value until it becomes equal 0. After 3 times, if it is equal 0, then it stays while 1, which means stay here forever, and the code will stuck. If the connection happens, then it will print MQTT connected, which and here is a demonstration. I've connected this using external power because this needs 5 volts and it needs a lot of current. So I've connected external 5 volts here, and make sure when you connect external 5 volts, make sure to connect the common to the common and just supply the positive. And right now the serial monitor is opened. Let me increase the screen a little on this side so you can see better all the values. At the moment the value is 0, and when you run these dots, as you can see, it changes the direction, but we don't see anything, and the speed because the motor is stopped. When I turn it on, the motor is started. It shows the direction CCW, and at 40% at the moment on the serial monitor. And if I reduce it, you can see it's 20 or 30%. So at the moment the value is the step is 10%. And when I click on CCW or CW, the direction changed. We can stop it. From here we can from this gear you can click and edit layout, and then go to this speed, click and edit block. This is a block that we are going to control. This under the motor speed, click next, and as you can see here the step is 10. We can set it to 1, save the block, save layout, and let's start. Now we can go with a step of no, still not reflecting. Maybe we have to reboot, restart it. Yes, right now we can go with an increment of 1. Let me put this fan that comes with the kit. This will make a lot of noise, but let's try it. Right now the current that this draws at 5 volts, 810 milliampere. But if I change the direction, the wind will blow to this side. %. I'm going to connect the meter from the power supply so we can see the current. And here, let me set it to 0. Now the current is 0. Let's see if I can show you as well. No, this is not good. Oh, in here now. Now we can see it better because I set it at the proper range. Let's go to the maximum. As you can see, it shows 870 milliampere. But if I change the direction, that's 830, 93%. Let's go 100%, 970. So 100% at 5 volts. The voltage is exactly 5 volts.